Thank you very much. I will talk about urban design today, and for that I will introduce the issue of what we have to do. First, we have to understand that we have changed completely the situation, the condition today. We are in this global warming. As you know, there is this temperature that is changing. And we have different scenarios. You know, some scenarios, the temperature will be very high, like more like 6 degrees more than in the 19th century. But we are already at 1.1 degree more. What's happened in terms of the city, and especially today, also in Europe, it was different before. You know, in Switzerland, for example, or in France, it was more temperate during the summer, but it started to become very hot also during the summer. So we don't have only to fight against coldness in the winter, but also about heat inside the city during the summer. So we can see this problem of heat waves. So urban design, we have to fight heat waves inside the city. Then there is this phenomena of urban heat island. You know, it's more hot in the city than in the countryside. And I will show the reason of that. It's linked to the color of the city. It's linked to the thermal inertia of the materials that are used there. Then there is a problem of floods that are becoming more and more important. We can see here, and also inside the city, we have to deal with that. Then the question of pollution, air pollution, the PM2.5 pollution. We know that it's now a cancerous pollution. And we know also it was connected with COVID-19 epidemic because the virus was jumping on the PM2.5 pollution and it was spread around. So it's so there is this kind of connection between the pollution and the epidemic. So if we want to summarize what we have to do as urban design today, we have to reduce urban heat island, we have to manage flood, to reduce PM2.5 pollution, and to preserve biodiversity. So we need some real material for doing that. And we have maybe to change the type of vocabulary we are using for doing design in the city. So we can say that maybe wind, light, water, so it means climatic element become the material of the urban design. Then we can say albedo, effusivity, thermal emissivity are material value. Before we say it was more aesthetic value, but maybe climatic value can become important. And then convection, evaporation can be tools for composing the city. So I will show some example about that by presenting a series of projects we did. So the first one is a competition we won in Milan, in Italy in 2019 with Remcola's OMA for 2 districts of the train company of Italy, and it was to transform 2 existing areas that were abandoned for the train garage. And so we start to think what will be urban design today. And we group the idea of doing a new urban development, so new housing, new building, with a kind of public infrastructure. But this public infrastructure is not only a social infrastructure, it's also an environmental infrastructure. So it's So this is these 2, Parco Farini, Parco San Cristoforo, are becoming environmental infrastructure. So we say that the public space should not be only for human, but only for cleaning the air, for cooling the air, or for cooling the water. So we combine that and we create a kind of new plaza or new boulevard, and we call that limpidarium. So this is a kind of new type of public space that will clean the city. So the two limpidariums, the first one is for Farini, it's a 50-hectare district. So we start to try to cool the city by working on the wind. We know that, more, we can see here it was in real time, some temperature and Milan become very hot at some point. And so we propose to have this kind of green infrastructure. We can see it here. So it was to build a kind of park where we will try to cool at the maximum the air by having white surface, so it will reflect the heat of the sunlight, with having fontaine, when you have evaporation of water, it's a transformation of water to gas, take energy to the air and reduce the temperature of the air. And of course we have shadow. So we built a kind of very cool and fresh environment, and then from that, with the difference of temperature between the blue that is cold and the red that is warm, it creates a wind. So we propose to build a wind inside the city, like a cooling wind that will go in the new building in the new district. And then we did the same for the pollution. We create this limpidarium like a filter against pollutant. So for doing that, we have some type of trees. There is very specific trees that can a little catch the pollutant of the air, but also we can have some artificial rain sometime when the pollutant is high, because the PM 2.5, fall down with the rain. So we propose to, if the episode of pollution is high, to have this kind of that. And this is a new district. It's all this area. And what we did an analysis with software, to see, this is our proposal here, and to see and to place all the building with flow of inside the direction of the wind. So the building will not block the wind. Everything will be cooled down by the wind and cleaned by the wind. It's also the pollutant. PM 2.5 should also be removed and diluted by the wind. So we find some old typology of Milan, and we try to readapt them to this new situation. And then the regulation of the urban design, we say, sometimes in the politic of the city say you should not build a building higher than 50 meters, for example. But here we propose to have really climatic strategy for the reglementation of the building. For example, we say we should have white horizontal surface in order to reflect that, and then we say that the top of the building should be a little black in order to create a trap for the heat. Because if you paint everything in white, the light and the heat of the sun will go down and overheat the street. So here we keep the heat of the sunlight at the top of the building, so it's removed with the wind, and we preserve the ground of the city from the overheating of that. So we find some regulations like that, and then at the end, it's becoming the new district. So there is also a strategy that was interesting made by OMA for that. It was the idea that depending of the money, we don't know the future. So if we have a lot of money, it will become like that. But if there is no money, it will stay like that. So there is some different scenario. And these different scenarios are not, our project is not waiting for a certain amount of money to be built. It can be adapted to every type or every economical situation. So then this is the new district is all these things here with kind of a flow of air that can move there, and a new building. Then another infrastructure was for cleaning the water. It was on the south of Milan in San Cristoforo. And so here we propose to have a kind of limpidarium that will clean the underground water and create a kind of public space. So it's more like it can be an outdoor swimming pool that will host animals and humans, in a kind of in the same time that it's cleaning the underground water by phytogeneration with the plant. Another project we won in this competition, it was for a very important park in Taiwan, in Taichung, so it's a tropical climate. We won that in 2011, and it was open in 2020. So this is the site. It was an old airport. So all here it will be built, and the park start from here and finish here. So it's like a little central park. So it's in the middle of the district. And for doing the park, we say why we need to build a park in the city today. And then we come back to the original idea of the park that were made for cooling, for maybe drying, because it's a tropical climate. So it means it's hot and humid, and managing flood, and for cleaning the air. So it was like the strategy of the park was to work on these 3 layers: cooling, drying, and depolluting. And for doing that, we use some different strategy. First, it was strategy of convection. So we analyze this will be the future building that are currently under construction here, and we made a CFD, computational fluid dynamic simulation, to show where the wind will be the most important. And when you have some wind, it's cool the skin. When the temperature is lower than the temperature of the skin, there is this cooling effect. And where it's red, there is a lot of wind. Where it's blue, there is no wind. And so from this simulation, we transform the climate analyze into a master plan. And so we can say here it will be colder because there is more wind. Here it will be winter because there is no wind. And then we reinforce that by planting trees to double the cooling effect of the wind by a shadow effect of the trees. So this is these trees. All these points are trees, and then we create a path that will be always cooled by wind and cooled by the trees there. And where there is the most quantity of trees, we create some specific place. We call that the coolia. So it's like the land of the cool. And so I like this idea to give an identity with this kind of climatic value of the site. And then the program arrives, so all the leisure activity find place in the most colder area. So the type of trees were selected for cooling effect, so it's trees with a lot of leaves, or trees with a big leaf, or white leaf, to reflect the light and to keep a very big shadow under. And the strategy also of planting the tree are working by gradation, so there is very intense, like a dense forest, and then it's becoming more open and more open there. And for the ground, we find some different type of material for cooling, with a lot of evaporation. We will see that also so all the type of choice of the ground material of the trees are linked to this cooling, climatic cooling research. This is a view of the park, and then. About the water, so the strategy is to manage all the water from the new district. Our park is 70 hectares, and all the new district is 250 hectares. So all the water from the new district arrive on the park and is managed. The flood is managed on site. And so for doing that, we are creating some valley where the rain can be stored when there is a huge, important rain. And there is some different scenario of, general flooded area, or when there is more an exceptional one where the park can absorb all that things. So we can see here some photo of the park with a flood. So it's so the water go inside, and the park have this responsibility to manage the water before it enter the real city from the building and the street area. And then the last layer is about pollution. We analyze where it's more polluted and also more noisy. So this is, we can say there is some big street here, and so there is more PM 2.5 pollution, more noise, and far from that there is more clean area. And we reinforce that by planting a lot of trees, of depolluting trees, and also trees that have different specificity. And then we create the path, the clean path, and the clean path will be for all the children, baby care, and all the children activity will be far from the noise and far from the pollution. Then the type of trees are planted with this type of gradation and specifically chosen for catching the PM 2.5 with hairy leaf or resinous trees. And the material of the ground are also cooling ground, cleaning ground with some specificity like that. And then all together, because we work individually on this 3 layer, all together we have the cooling trees, the drying trees, and the depolluting trees, and so it's overlap, and it creates a diversity of microclimate, so it can be cool, dry, polluted, or cool, dry, non-polluted, or hot, dry. So there is a diversity of climate that are built there. So this is some image of that, and I want to present some part of the park, specific park. So one specific area is at the top of the park here. We have 7,000 square meters of photovoltaic panel that produce all the electricity of the park and more that we need. So we can see the panel. It's like a canopy, so it's like an elevated roof, and so we analyze everything. We can see the master plan of this roof, and it's covering some car park, but also some landscape, some building, so some different type of activities under. And so this is this large structure, and then it's quite interesting because it's it's create a kind of a more temperate landscape where you can escape from the heat from the sun. In Taiwan, it's quite tropical, so not too far from the equator, so the sun is quite intense, and so the excess of sun, in a certain way, we use that for producing electricity in another moment. So we can see this kind of landscape so sometimes there is some nature and some different type of building. Then another work we made also for this park was this meteorological garden, and the strategy was to say, okay, during the 19th century, maybe we have invented the street lighting, like to build a sun during the night. So is it possible to build the winter during the summer, or to build some cooling device for when it's too hot? And for doing that, we are using only renewable energy, so all the electricity are produced by photovoltaic panel, and all the cooling effects are produced by geothermal cooling. So this is some example of these devices that work by, some of them are working by evaporation, some of them are working by radiation or by convection. So this is by blowing, lowering air temperature or evaporating. So we have the electricity that is produced at the here, and it's a small part is used for this garden. And this is geothermal cooling. We made some tests on site. You see, sometimes it can be 40 degrees Celsius on the ground of the park, and under 5 meters underground you find 25 degrees Celsius. So by going underground, we can cool the air, and then it comes back and it's blow some cold air naturally, like that. So we can see the system of this underground pipe inside the park, and then it go out with all the pipe, and the pipe are becoming the leg of the cooling device, and then we do with our engineer some test of calculation of the quantity of air, the speed of air with the CFD. This is a German company, Transsolar, that did this modeling to calculate the quantity of air, the volume of air that should be blow, and then we have this kind of shower of cold air, when it's very hot, that will be blow on the park. So it's a little like to say, okay, for cooling we can have different strategy like in the traditional 18th century park we have some grotto or some kiosk, and so this is a little this kind of fabric that are for cooling with some cooling effect. This is another device for cooling. So it's we know that by evaporation. So we have a pipe of water and that create a mist of water, and that cloud that is a kind of cooling cloud, and so we can see, yeah. And then for the master plan, one strategy was to place every 50 meters. We have a sensor. We have that. We have some sensors that measure that are measuring in real time the temperature, the humidity, the pollutant, the wind, all the climatic value, and this go. This we can see here. This kind of this, and it go to the computer, and then it's creating in real time some map. So we have the cool map, so and with the gradation. So it's here it's very hot, here it's very cold, and so you can, and then we have the same for the humidity, and then we have the same for the pollution with, for example, the ozone and NOx and PM2.5 and noise. So there is some different analyze, and then it's go to the iPhone, and with that we can decide where to go, because it's creating map, and so if you are looking for coldness, you can see, on your interactive map where to go. So it's create a kind of new type of decision where to go where to move, or to move in the park. I will present two other projects. One project is a competition we made for München in Germany. So we get a prize for that. It was with a German office power plan. And so the project was the development of the city of, so it was 700,000 hectares on the northeast of the city of Munich in Germany. And so what we did for that, we analyzed where there is some existing small village, existing urbanization, and we reinforce the existing urbanization by densification, and we keep all the space in between open and free for managing biodiversity, flood, and flow of cold air, and animals. So this is what we can see here. So there is always in between a gap that let the air moving inside the city. So we can see different developments. So here it was like for 10,000 new inhabitants and 20,000 new inhabitants and 30,000 new inhabitants. So it was like a strategy of a long-term strategy. And so this is this kind of space in between here that are open to the biodiversity and the flood, and for doing also the type of building here we can propose. We did also this computational fluid dynamic analysis. So we are modeling the wind, and we see, we don't want to create some block that are closed and the wind cannot enter. We want to cool, but to let the wind going. So this is this kind of choosing, analyzing how the wind can enter the new block, and let the cooling effect made by that. And then I will finish with another last project. This is a project we are currently developing since a few years. It's part of the transformation of the port of Bassora in Iraq, and so there is an oil port there, and there is a transformation of this port, and currently, before that, the port was on the river that go to the sea, and then all this will go somewhere else, and the request was to transform this industrial area into a new housing and building and leisure new district in this year. And so this is like it is. And so the city is here of Bassora, and so today there is no connection. It's a little like what's happened in in a lot of cities in the world. There is this the river was used for industrial activities, and then it moved somewhere else, and so the city go back to this kind of landscape, like in Bordeaux, for example, or in France, and so our design was to rethink about. It's almost 2 kilometers of here. And so we propose to have 1 kilometer of shadow. This is the title of the project, 1 kilometer of shadow. So to create in between the river and the city, a new public space here that will be covered by photovoltaic panels that are producing electricity, but also creating shadow and more colder climate space. And so this is this 1 kilometer of shadow, and then there is a new district, new building there. And so here it's a mix of, we can say, vernacular architecture of Arabic country, like in Sharjah or with a small street, narrow street, in order that the sun cannot go deep inside the street, and with some openings that are not facing the sun, but more on the shadow. So we did some specific recommendation for that, and then there is some tower that was planned at that moment, so this is like the boulevard is the boulevard is here, and then it's here. What's that? And so this is a new district, and this is 1 kilometer of shadow, and then this is the access to the river. And under the shadow, we propose to have some different pavilion, some different activity, cooling activity that will all become also some point of interest when the people will go there. So, okay, this is this shadow, and then the new district here, and this is like the section with this shadow here. And the different activity we propose there, we have this the oasis square, the thermal inertia square. So we use some climatic value to create that. So I can show some example of that. So the dark space, so it's under the canopy, the photovoltaic panel. So this is like layer inside another layer, inside another layer. So more you go inside, more it become, you are escaping the sun, and more it's becoming dark. So this is like a radiation transition from the super sunny area to a more dark and shadow area where you can be protected by that. Then this is the inertia square. So the principle is to cool during the night. During the night the temperature is a little lower, so it will be absorbed in the mass of the stone, and so store inside, and then during 12 hours you delay, by thermal inertia, it's keep the freshness inside the space. So it's becoming like a kind of a grotto for that. Then there is a solar chimney. So it's to produce wind. We paint in black the top of the chimney, so it overheats under the sun, and then it becomes very hot. And because it's hot and cold down, it creates a wind. And so it will be super windy inside, and you'll be cool in a natural way there. This is more classic, with a kind of garden of trees. And yes, and so yes. So I'm done with my presentation, and so I have this image of this is a small book in French about this meteorological garden. And so thank you, everybody.